Bismillahirrahmanirrahim. So first of all, as you might notice, I actually skipped two activities because I think they are trivial, and we want to get to the important things. So in the material, one important topic was the classification of the port numbers, and as we said, the port numbers, they represent the identification of the applications on both sides. So these port numbers, because the port number ranges from 0 all the way to 65,000 something, because it's 16 bits, this range of 65,000 numbers is actually divided into three sections or three categories. There is the category of what we call well-known ports, and these well-known ports are typically used for server services that are common and well-known, like HTTP is the most common طبعا, FTP, Telnet, IMAP, POP, all these services are well-known services. So in that case, as you can see here, the port numbers are actually represented by the name directly, because these are port numbers, by the way. These are port numbers, but because these port numbers are for well-known services, we use the name to represent the port number. So when we see HTTP, we know that this is port 80. When we see Telnet, we know that this is port 25. When we see FTP, we know that this is port 21 and so on. So if you try netstat command on your machine, you will see the well-known services are represented by the name, but these are actually port numbers. Okay? There is the range of what we call registered ports, and these are from 1024 all the way to 49,000 something. This is called registered ports. Registered ports are used also typically for servers or for peer-to-peer applications that are not well known. Like for example, messaging and chat services. These are like not well known like HTTP. It's mainly used for proprietary protocols and some of voice over IP services. So, or when you design your own service, like peer-to-peer application, for example, you may select a port in this range, registered range. Okay? And from 49,000 something to all the way to 65,000 something, this is what we call dynamic. This dynamic range is used to represent the client or the source port if your machine is acting as a client. So typically, when you open your browser and you open a different tab, each tab will get assigned by the operating system an arbitrary port number in this range. Okay? So this is called the dynamic range. So if you have like three tabs, and these three tabs, they are using on your browser, which means that they use HTTP, okay? Because HTTP uses TCP. Each tab will get a different source port, okay? And all the three tabs, they will use the same destination port, which is port 80. And this is the scenario that we have here. And we'll try to answer these questions based on these lists. Okay, so from this list, we know when this node or this machine is acting as a client, when this node is acting as a server, how many connections in which state. This is the state. Okay? So as we said, the operating system will have this dynamic port range as a pool, free pool to get any arbitrary number from it and assign it to each tab or each application. Whether this tab uses Telnet or FTP or something like this, all of them, they use port number in this pool. And of course, the rule is you cannot have two applications use the same port number. use the same source port number. So if you have a tab on the browser, if you open another tab, it has to take a different source port. Two applications cannot have the same port, or in that case, when you open the socket, the TCP will reject that. Will tell you that this port is in use, I cannot use it, which makes sense because when the response comes back from the receiver, I will not know if I have two applications with the same port, I will not know which one I should send this segment to. Okay, so in that case, each application has to have a unique port in this range.
Can we use the same port, but an application uses a TCP with this port and another application using a UDP?
Yes, because the categorization now the separation happens based on the protocol, not based on the application. So the network layer has the protocol field which tells it whether to put it to TCP or UDP, right? So now TCP will put it in the applications that use TCP connections, and UDP will put it in one of the applications that use UDP connections. So theoretically, you can start two connections with the same port if one of them is TCP and the other one is UDP. In that case, you would not get the message port in use. You can do that. Okay, Kayla? So we need to quickly answer these questions based on this netstat list. And just quickly, here we say that connection established or listening. Established here means that the connection is established, which means that this machine, this is the machine name, by the way, okay? This machine is now communicating through these connections because the connection happened already bidirectionally, and it's ready to communicate back and forth some messages. Listening, it means that I'm listening, but no one has connected to me yet. And this typically happens when you say, on one side, socket open. When you say socket open, you start a server connection on the machine, and this connection will keep listening to any incoming requests to connect to it. But the connection did not get established yet. So this is the difference between listening and established. Of course, there are so many other states, but we don't have to worry about them. These are the two only states that we need to know about at this point in time. Okay? So we need to answer these questions by just putting some numbers here based on this list. So this is just to allow you to be able to understand this list and what each column means. So we know that this is the remote IP address or the remote host I'm trying to connect to. This is the port number. If the port number is in the well-known range, then I put the name to represent the port number, and so on. And this is the state of the connection. So answering these questions will become very easy. Okay? The local host has how many client HTTP connections to destination, to a specific destination? So in that case, this destination is this, right? So we have 2. The local host has how many client HTTP connections to destination 152? Now it's only one. The local host has how many server HTTP connections? 1. Just one. Which one? The last one, right? So here, the source port is port 80. In which case, this machine is opening a socket, a server socket, okay, on port 80. Okay, so this is 1. How many connections are in the established phase? 6. Only 1 is in the listening phase, which means that the connection has not been established completely yet.
Can you explain the last one?
The server connections, server HTTP connections, because all of these are client connections. All of them are client connections, right? So there is yet another typo here, because these ports are not in the dynamic range.
Yes.
But this is wrong. These ports should be in the dynamic range, because the dynamic range starts from 49,000 something. If you try Netstat now on your machines, you will see that the client connections, they all get assigned port numbers in the dynamic range, which means that they are 49,000 and up.
The next one, how many connections are in the establishment phase? That means
In the established
connections
phase.
that are going to be established, not
No.
established. Right? Establishment means it's going to be, it's a phase to go to establish.
Yeah, well, yeah, the wording is not correct. The wording is not correct. Yeah, if in the establishment phase, yes, then
They're going to be established. Not,
in that case it's 1,
yeah.
which means that actually it's 0, because
Nothing. This one's listening.
yeah, this one is listening, so the connection is not actually starting yet. In the establishment in the establishment phase, this means that we will see in a minute either sync wait or sync acknowledgement wait or acknowledgement wait or something like this.
It's before establishment.
Which means that, yes, before it becomes completely established. So, yeah, but here what I meant is that in the established phase, not in the establishment phase.
Could you repeat the first one? Why is it 5?
5, many connections use destination port 80. As we said, port 80 is in the well-known range, so all of these have port 80. Okay, so which means they are 5. Okay, so yeah, of course this one is trivial. This one is easy. I think you will be able to do it, but we'll skip it to the important thing, because this one is a little bit. It needs a little bit of explanation. So, so to understand this activity, we need to explain first the control flags. So, as we said, the control flags, we have 6 control flags. We have the urgent pointer, we have the acknowledgement, we have the push, we have the sync, and we have the fin, and we have the reset. Okay, so these are 6 control flags. So very quickly, we'll go through them very quickly just to explain what each one is used for. There is a similarity between urgent pointer and push. They both indicate that this data is important and of high priority, and you need to process it now. Because normally, when the application sends information to the TCP layer, TCP will put it in a buffer, and then we'll start going through the buffer one segment at a time, right? So just the fact that the application sends some information, it doesn't mean that I will process it now. It will be put in the buffer, and then I will process the buffer in sequence, right? The push means that you don't have to follow the order. You have to process it immediately, because this contains very important and high priority information, and you have to process it immediately. The slight difference between push and urgent, we have an urgent pointer. We don't have a push point, which indicates that for urgent, maybe part of the segment is urgent, not the whole segment. So in which case, this is an indication to the receiver that if the urgent flag is set, you need to go to the urgent pointer and point to the part of the segment where it contains the important information or the urgent information, not necessarily the whole segment. For push, it actually forces both the sender and the receiver to process the segment immediately, without following any order. Okay? So this is the slight difference.
Why would us use the urgent even if the TCP is already slow?
Actually, this is to overcome the fact that TCP is slow, because as we said, some streaming applications for example, or maybe very important control messages that I need to process at this point in time. If I wait for its order to be processed, I have to wait forever. Okay? So TCP gives you this flexibility to try to enforce your segment to go out of order and to be processed now. Some streaming applications, they use TCP together with this feature to overcome the large delays of TCP. Okay? So that's one feature that tries to overcome the limitation of TCP regarding large delays. Type. The urgent flag, when you set it, طبعا the acknowledgement flag is used for reliability. When you set the acknowledgement flag, this means that the acknowledgement number will give you the number where the one node is telling the other node that I received up to this point everything fine. So if I want to indicate an acknowledgement in this segment, then I set the acknowledgement flag to 1. If the acknowledgement flag is set to 0, this means that the acknowledgement number is don't care. I don't care about this. It's all zeros, which means that this segment does not represent or does not inform the other side that this is an acknowledgement for anything. It's just data, because not all the time I need to send acknowledgement for something. Maybe at the beginning of the communication, I need to send data, but I do not have to acknowledge anything yet, right? So in that case, if I want to indicate that this is data and acknowledgement for another segment, then I set the acknowledgement flag to 1. The sync is synchronization. So I synchronize up to in the sequence number in that case will indicate the start of a new synchronization. So for example, at the beginning of the connection establishment, I'm telling the other side, like A will inform B, that I want to synchronize and I want to start from this number. This number, by the way, it doesn't have to be 0. And typically it's not 0, even in the beginning of the communication. So I don't have to start from 0. So A has a buffer, and it receives the information from the application and it puts it in this buffer, and then it does the segmentation to put in this buffer some segments, and then it starts from any arbitrary number. In that example, actually, A will start from 300. Okay? And because TCP facilitates bi-directional communication, A wants to send some information to B, and B wants to send some information to A. So also, B has a buffer, and this buffer has certain segments, and it also, the synchronization from B side, it doesn't have to start from 0. So in that particular example, B starts from 100. And these numbers are not correlated. They don't have to match. Because remember that this is bi-directional communication. A wants to send to B some messages, and B wants to send to A some messages. Okay? These messages, they are correlated in the application layer. But TCP deals with this as abstract segments, right? And the segments going from A to B or from B to A through the same TCP connection. Because one TCP connection is bi-directional, right? So now A wants to synchronize at 300 and B wants to synchronize at 100. There's no obligation whatsoever. And these numbers are correlated or they have to match or anything. Okay? The fact that they do not start from 0, they discuss this in the standard that it has some hatta security implication. Okay? So if an attacker listens to the connection in the middle, so it sees an arbitrary number, it doesn't know that this is the beginning of the message or in the middle of the message or something like this. So this actually increases the security. But in general, in the standard, the synchronization doesn't have to start from 0. Okay? Now this is the sync. The fin has an important meaning. It's used typically during disconnection, but it actually means I finished sending all my segments to you. That's what it means. It doesn't mean disconnect. It means that I don't have any more segments in the buffer to send to you. That's what it means. Okay? Because the enforcement for disconnection is actually reset. Reset, it's activated or triggered when you say socket.close. When you say socket.close, this is like immediate disconnection on both sides. Or it sometimes happens when A wants to connect to B, but B wants to reject this connection. So it sends back an acknowledgement with reset flag set to 1. I don't want to connect to you. I want to disconnect this immediately. Okay? The danger or the risk with reset, as opposed to thin, reset disconnects immediately. Even if you have any segments in the buffer, they will be lost. Okay? Thin, it's typically used for graceful disconnection. A is telling to B, I don't have any segments for you, but B still has some segments. So B may select to keep sending whatever segments in the buffer to A. So in that case, A will receive the segments, but A does not have any data to send to B. And then when B finishes, B will send fin, another fin, which means that I don't have any data to send to you. So in that case, it's a graceful disconnection. A doesn't have anything to send to B, B doesn't have anything to send to A, so this means that خلاص, the connection is gone. But the problem with reset is that if one of them sends reset, regardless of whatever any data in the buffer, it's خلاص, it's gone, it's lost. So B is for this immediate disconnection, but typically for TCP it uses graceful disconnection, which means that we use fin to gracefully disconnect. Okay, so this is the slight difference between the two. So very quickly we want to establish the scenario for establishing or starting a connection. So typically what we need to do, is we need to write the sequence number for each segment and the acknowledgement, if it is an acknowledgement. Okay, and in a separate line we need to include in this control field what flags, if any, that needs to be set for this message. Okay, so if I want to establish a new connection, I want to use the sync flag. If I want to establish a connection and at the same time acknowledge a message, then I need to set two flags, the sync flag and the acknowledgement flag, and so on. Okay, so just to organize things, put the sequence numbers and acknowledgement number in one line and the control flags in a separate line, just to make it clear. Okay, so for each segment, the minimum you have to do is to set the sequence number. So there has to be a sequence number. Okay, so here we need to sync from 300, which means that the sequence number will be 300. Okay, at the beginning we don't need to acknowledge anything, so no acknowledgement. And since we want to establish a connection, so we want to set the sync flag, right? Because it's not an acknowledgement, we don't need to set the acknowledgement flag to anything, so that's it. And when we send the message, so this is the message, so now we need to send it. When you send it, you represent it by a diagonal line, because the message does not arrive there in 0 time, right? So there is a time. This is the propagation time and the transmission time. Okay? It arrived here, which means it's received. أو sync received. So now B will process it, will analyze this message, and will realize that now I want to send two things. I want to send an acknowledgement, and I want to synchronize back. Okay? TCP gives you the flexibility to combine those two into one. But typically they are two separate segments. One is to acknowledge, and another one to sync back. So this message is a combined message that has two pieces of information. So this message has a sequence of a 100. I want to sync starting from 100, which has nothing to do with the 300. Okay, so the sequence is 100. What is correlated to the 300? The acknowledgement. The acknowledgement now tells A back that I received 300 up to 300, I received everything correct. Send me 301 or send me the segment after that. That's what the acknowledgement means. Always the acknowledgement is incremented or it's above all the bytes that you have received at this point in time.
By one.
So by one or by the length or the number of bytes in the segment.
Which is in this case.
In that case, it's 0. In that case, it's 0 because I'm not sending any data back and forth yet, right? These are empty control segments just for establishing the connection. The data size for these segments is 0. Yani, this segment has TCP header but no data. If these segments has a length of 100, then the acknowledgement here would be 401, which means that I received up to 400 bytes correct, which is, we started at 300 plus 100, okay? Send me 401. That's what it means. At the establishment phase, okay, the data size is 0. These are only control signals sent back and forth to establish the connection. Before doing, because as we said, this is one important pillar of TCP, connection establishment. I cannot send any information without establishing the connection. So during the connection establishment, I don't send any data, any actual data yet. So the segment size is 0. So the acknowledgement number here will be this 300 plus 1 at least, or plus the segment size if there is any data. This is the rule. Okay? And this message will have control, and now the control, as we said, this is actually this message. We want to sync back, so it has a sync flag set to 1, and we want to acknowledge the fact that we have received your sync. Okay? So this segment is actually a combined segment that has two pieces of information. We send it back to A, and now A will say receive, which means I received it. So now A will have to acknowledge back at least. Okay? We'll have to acknowledge back. And if it has any segment in the buffer, it may actually send it together. But let's say that it's not yet, so the buffer is still empty, which means that we did not establish the connection yet. So the application doesn't know that the connection has established. So the application did not send me any information yet. Okay? So in that case, the least I could do is to send an acknowledgement. The sequence number, as we said, all messages have sequence. The sequence number is A. وريني قول لي بقى عشان اعرف انت مركز ولا لا. 300 and لا 301. ما هو الاكنولجمنت ده is telling A I received up to 300 fine, send me 301. So I'm telling you, here it is, 301. Okay? And acknowledgement is إيه
101.
101, right? So I'm telling B, I received up to 100 fines, send me 101, right? And the control flags, we have the acknowledgement and nothing else. Nothing else, right? Okay? Now, this one is received and connection established. So now the connection is established. So the applications in the application layer will be notified that now the connection is established. You can send information on either side. So after some time, if this is like HTTP application or something, after some time, because typically A is the client, A is the one that initiated the communication, right? So typically A is initiating the communication because it wants to send something. So typically A will start sending information first. So if this is HTTP, the buffer here will be filled by HTTP segments, and now A will start sending these segments as data later on. Okay? Now that the connection is established, you can flow messages back and forth. And then B will acknowledge and send data back. So you can combine the two, acknowledgement and send message. If you don't have any messages to send, you have to at least acknowledge. If your buffer is empty and you don't need to send anything, خالص, then you say a fin, which means that I finished sending all what I have to you, and I don't have any more segments to send to you. So we start the disconnection phase, which is what we will talk about next time.
So sequence flag is for sending and acknowledge is for receiving?
Yes. But not every segment has to be an acknowledgement for something, صح? يعني at the beginning of the communication, you don't have to acknowledge anything, صح? In that case, you need to set a sequence bus. In that case, the acknowledgement number could be 0. And you set the acknowledgement flag to 0 to indicate that there's no acknowledgement in this segment. If you want to send a segment and to say that there is an acknowledgement in this segment, then you have to set the acknowledgement flag to 1. ماشي كده؟ Okay.